Bismillah ar-Rahman ar-Rahim. Let's complete the exam view for chapter 5. This is the third part. Number 41. A push دفع of magnitude مقداره P acts on a box of weight W. This is the push, or this is the force P acts on a box, its weight W. As shown in the figure, the push الدفع is directed at angle theta below تحت الهوريزونتال زي ما أنا شايف كده. And the box remains at rest, so total force equals 0. The net force equals 0. The box rests on horizontal surface, سطح أفقي, that has some friction, في بعض الاحتكاك, with the box. The friction force on the box due to the floor is equal to. Here is friction force, F in opposite direction of the push. So let's resolve the push force. This is the force. It has two components. The one near the angle takes cosine, so P cosine theta. The one perpendicular takes sine, so P sine theta. So, and the weight downward and the normal force upward. Right, guys? So if you want to draw the free body diagram, this is W and also P sine theta from the pushing force, also toward above. This is the normal force. This is the push force, x direction B cosine theta, and this is F friction. F friction, as you see, the net force equals 0. The net force in x direction equals 0 and net force in y direction equals 0. So F equal P cosine theta. F equal P cosine theta. This is the answer. Letter B. Let's go to number 42. In the figure, what does the spring scale reads? This is a scale, the spring scale. Read. The pulleys are ideal and the string and the scale are also massless. So this scale doesn't have mass, and those ideal means they do not have any friction. So if this box 1 Newton and the other 1 Newton, so the tension here in the wire or the string or the scale is also 1 Newton, not more, not less. So 1 Newton exactly. The answer is B. Let's go to the next one. What is the mass of an object that experiences a gravitational force 685 Newton? Means its weight. 685 Newtons near Earth's surface, and he gives you the acceleration due to the gravity. You know well that weight equals mg. So he needs the mass. So mass equal weight over g. Weight is 685 Newtons. G 9.8. So it equals 69.89. Approximately 69.9 kilogram, because it is mass. This is the answer. So the answer is A. Let's go to the next. If I weigh 740 Newton on Earth, this is my weight on Earth, at a place where G 9.80 and 5,320 Newton on the surface of another planet. What is the acceleration due to gravity on that planet? At the beginning, from this information, we can get the mass, right? Mass equal weight over gravity. It equals 741 over 9.8. So I'll get my mass on Earth, and it is the same as my mass on any place because mass is constant, right? Mass doesn't change from place to another place. So by dividing 741 over 9.8, we get 75.6 kilogram. This is mass. He gives you the weight on another planet. So weight, you know well, equal mass times the gravity. Weight on the planet, another planet, equal mass is constant and G on the other planet. So G on the other planet equal weight on this planet divided by constant mass. So he gives you the weight on the other planet, 5,320 Newton, over the same mass, 75.6. It equals 70.35 meter per second square, because it is acceleration due to the gravity on this planet, 70.4 meter per second square approximately. So the answer is letter A. Let's go to the next. An astronaut رائد فضاء weighs 99 Newton on the moon, where the acceleration of gravity there on the moon 1.62. How much does she weigh on Earth? So at the beginning, we can get the mass on the moon, right? What is the mass on the moon? Mass on the moon or on any planet equal weight on the moon over G on the moon. So weight 99 over G on the moon 1.62. It yields 61.11 kilogram, and this mass is constant. This is constant. So how can I get the weight on Earth? It's so easy. Weight on Earth equal mass, and we don't need to write M here because mass is constant, time gravity on Earth. And you know well the gravity on Earth 9.8. So 61.11 times 9.8 equals 598.8, approximately 600 Newton. So the answer is letter D. Let's go to the next. 46. An object has a mass 60 kilogram on Earth. What are the mass and weight of this object on the surface of the moon, where the acceleration due to the gravity 1/6 of what it is on Earth? At the beginning, mass is constant everywhere. So mass on the moon equals 60 kilogram. Weight on the moon equal weight on the Earth but multiplied 1/6, because if we get weight on the Earth, multiply 1/6, you will get the weight on the moon. Right, guys? So, what is the weight on the Earth? M60 times gravity on the Earth, right? So, it is about 1698. It's only 98. So this is the weight on the moon, right? So because he asked what are the mass and the weight of this object on the surface of the moon. How can you calculate the mass on the moon? It is constant as the mass on the Earth. Type. What is the weight on the moon? He gives you an information that the gravity on the moon 1/6, the gravity on the Earth. So the weight on the moon 1/6, the weight on the Earth. Let's go to number 47. A net force 125 Newton is applied to a certain object. As a result, the object accelerates with an acceleration 24 meters per second square. What is the mass? You know well that the summation of the force or the net force equal MA. The net force 125 equals the mass, you need the mass times the acceleration 24. So mass equal the one here next to the mass goes denominator 125/24. It is 5 point something. So 5.21. What is the unit of the mass? Kilogram. You need to write always the unit because a number without a unit meaningless. Let's go to the next. If a net force accelerates 4.5 kilogram tool at 40 meter per second square. So I have net force effect on 4.5 kilogram. It accelerates 40 meter per second square. What acceleration would that same net force give to 18 kilogram tool? So the force is the same, right? So the force equal MA. So M1A1 equal M2A2 because it is the same net force. M1 4.5 times A 40 equals M2 18 times A2. So how can we get A2? So 18 goes here. So A2 4.5 times 40 over 18. It equals 10 meter per second square. I hope it is easy for you. So the answer is B. So as you see, small mass, large acceleration. Larger mass, smaller acceleration because the net force is constant, the same net force. Let's go down. On frictionless table on Earth, the block accelerates at 3 meters per second square when 20 Newton horizontal force is applied to it. So, from this information, F equal MA, we can get the mass. So, M equal F over A. So, M equals F 20 over A3. So it is 6.67 kilogram. So now I know the mass. And the mass on the Earth is the same as the mass on any place. The block and the table are set up on the moon, where the acceleration due to the gravity is 1.62. He needs the weight of the block on the moon. So I have the mass. So weight on the moon equals mass times g on the moon. So mass equals 6.67 times 1.62 equals 11 Newton. So this is the weight on the moon. So the answer is A. Let's go to the next. A block is on frictionless table on Earth. The block accelerates at 5.3 meter per second square when 10 Newton horizontal force is applied to it. So from this information we can get the mass F equal ma, so m equal F over A. So m equals F 10 Newton over the acceleration 5.3, so it is approximately 1.88 kilograms. The block and the table are set on the moon where the acceleration due to the gravity is 1.62 meter per second square. It's okay. A horizontal force 5 Newton is now applied to the block when it is on the moon. The acceleration imparted to the block by this force. So you know well that F equal ma on any place. Here on the moon we have 5 Newton applied on the same object and the mass is the same, so we will take 188 times the acceleration. So the acceleration equal 5 over 1.88. It equals 2.65 meter per second square or 2.7 meter per second square approximately. That's it. So the answer is letter A. Let's go to something else. 40 kilogram crate is being lowered with a downward acceleration is 2.0 meter per second square. The direction is downward. The acceleration 2 meter per second square. This is Fy. It is downward. What is the magnitude of the force exerted by the rope on the crate? The means he asked about the tension. Here I have the weight W. Right, guys? So from the equation Fy, and as you see Fy downward means MAY equals weight on the same direction minus the tension that he needs it. So T equals, T goes on the other side, W minus MAY. So T equal W means mg minus MAY or mg minus AY. So 49.8 minus 2 equals 40 means 312 Newton. So this is letter A. What about letter B? What would be the magnitude of the force exerted by the rope if the crate were being raised with an acceleration 2? So imagine that the crate is going upward. So the direction is the direction of the force upward, Fy upward, and the weight downward. So MAY equal the tension in the same direction minus W. So T equal W, the weight means mg plus MAY means mg plus AY equals M40. 9.8 plus 2, it yields, just a second, 40 times 11.2 yields 448 Newton. I hope it is easy for you guys. 52. 450 kilogram sport car accelerate from rest to 100 km per hour in 4 seconds. From this information, what we can get? Here V initial, here V final, so T, so we can get what? the acceleration. But at the beginning, V final here in kilometer per hour, so we need to convert it to meter per second because here is second. So V final, or you can get delta V. Delta V, V final minus V initial, delta V equal 100 minus 0 equal 100 kilometer per hour. It equals 100 times 1000 to convert it to meter, and hour 3600. Let's check how much we got. Let's check how much we got. It is so easy, guys. It gives you 27.78 meter per second. This is the difference in or increase in or the change in velocity. How to get A equal delta V over T. So A equal 27.78 over 4.8. It equals 5.787 meter per second squared. So we got the acceleration. What magnitude force does 68 kilogram passenger experience during the acceleration? So we can get the force that the passenger experience from this equation, MA. So F for the passenger 68 kilogram times 5.787, it yields 394 Newton approximately, guys. So the answer is letter A. Let's go to number 53. On its own, a tow truck has a maximum acceleration 3 meter per second square. Okay? What will be its maximum acceleration when the truck is using a light horizontal chain to tow a bus? This is the truck and this is the chain to tow the bus. Twice its own mass. Twice its own mass. The force that the truck is used, it is the same. So F equal MA, M1A1 equal M2A2. M1 for the truck alone, right? Times the acceleration was 3. M2 now, the truck plus twice its mass. So M1 plus 2 M1 times A2. So M1 times 3 equals 3 M1 times A2. M1 goes with M1. So 3 equals 3 A2. So A2 equals 1 meter per second square. I hope it is easy. This is D. Let's move to 54. A car of mass 1100 kilogram that is traveling at 27 meter per second start to slow down. This is negative acceleration and comes to a complete race stop. So we have V initial equal 27 meter per second, V final equal 0 meter per second in 578 meters. So the distance 578 meters. From this information, I can get the acceleration. Do you remember this equation? 2AS equal V final square minus V initial square. So acceleration equal V final square minus V initial square over 2S. So A equals V final square 0 minus 27 square over 2 times the S displacement or distance 578. So acceleration here is negative because it is slowing down. it equals negative 0.63 meter per second square. Type. He needs what is the magnitude without a sign, magnitude only number, without direction. Average braking force, the forces that used to in brakes. So we don't need this charge, okay? Because there is no charge here. We don't need this negative sign. How to get it? That's so easy. F equal ma, the mass of the car 1100 times 0.63, it equals, just use the calculator, 693.6, approximately 694 newtons. So we don't have it, but we have 690 newton because he doesn't write, he make like approximation rounding. So the answer is A. Let's go to next 55. A certain aircraft has a mass. He gives you the mass of aircraft at a certain instant during its landing. So it is deceleration, slowing down. Its speed 27 meter per second. If the braking force is a constant, this number, what is the speed of the aircraft in 10.0 seconds later? So at the beginning, can you get the acceleration from this information? Yes. You know well that F equal ma, so acceleration equal F over m, so acceleration equal the force 445,000 over 300,000. So A equals 1.48 meter per second square. But hold on, what is the speed of the aeroplane? So put in your mind this is with negative sign because it is landing. It is deceleration, right? So you know well that V final equal V initial plus AT, V final equal V initial 27 plus negative 1.48 times time 10 equals 12.16, approximately 12.2 meter per second. So the answer is letter B. You know why I use the negative sign? Because it is a force opposing the motion. So it is deceleration, negative acceleration. Let's go to number 56. What magnitude net force is required to accelerate? This is mass. Uniformly from to in. So you can get the acceleration, guys, from 0 to 27. So V final minus V initial over T. So acceleration equal 27 minus 0 over 10. So acceleration equal 2.7 meter per second square. Right? You know well that F equal ma, m 1200 time the acceleration 2.7, it yields, using calculator, 3,240 Newton. Do we have this number? Yes, C. Let's go to next. A catcher stops 0.15 kilogram ball traveling at 40 meter per second. Stops, so V final equals 0. And this is V initial. A distance 20 centimeter. The distance in centimeter, we need to convert it into meter, so divided by 100, 0.20 meter. What is the magnitude of the average force? Can we get the acceleration from this information? Sure. V initial equal 40 meter per second. V final equal, he will stop it, 0 meter per second. The S equal 0.20 meters. So you know well that 2a S equal V final square minus V initial square. So S equal V final square minus V initial square over 2a. So S, the displacement, A, the acceleration, equal V final square 0 minus V initial square 40 square over 2 times acceleration. What is the acceleration? Sorry, it is not acceleration, it is S. I need to get the acceleration, guys. S is 0.20. So A equal, use the calculator, you will get the acceleration equals 4,000 meter per second square in negative sign. He need the magnitude of the average force, and sure it is negative acceleration, deceleration, because you will stop it. So F equal ma, we don't need to use the negative sign. We know this force opposes the motion. So m 0.15 times 4,000, it equals 600 Newton. So the answer is 600 Newton. Let's go to the next. An object that weight 75 is pulled on horizontal surface by a horizontal pull of 50 Newton to the right. So I have the weight 75 Newton and there is a force 50 Newton to the right. The friction force on this object is 30 Newton to the left. There is 30 Newton here, friction force. So the net force equal 50 minus 30, because it is in opposite direction. It opposes the motion, right? So the net force equal 20 Newton. He needs to calculate the acceleration. To calculate the acceleration from this equation, F equal ma, we need to get the mass. Can we get the mass from this information? Yes. You know well that weight equal mass times g, right? So m equal, what is the weight? 75 over 9.8. It equals how many kilogram? 75 over 9.8. It equals 7.65 kilogram. Wait, we didn't finish. We need to calculate the acceleration. A equals the net force over m. So 20 over 7.65. It equals 2.6 meter per second square. I hope it is easy, guys. Let's go to the next. $1,200 car is pulling 500 kilogram trailer along level ground. Okay, friction of the road on the trailer is negligible. There is no friction. The car accelerates with a 1.3 meter per second square. What is the force exerted by the car on the trailer? The force exerted by the car is F equal the mass of the car times the acceleration of the car. It is the same as the acceleration of the trailer. So the mass of the car 500 times the acceleration 1.3, because they are moving together, guys. So 650 Newton. This is the answer. We have it. Yes. Let's go to the last one in this section. In a certain particle in accelerator, a proton reaches an acceleration of, this is the acceleration. The mass of the proton, this is the mass. What is the force on this proton? You know well that force equal mass times the acceleration. So M equal 1.67 times 10 power negative 27 kilogram times the acceleration, he gave it to you 9 times 10 power 3. So the answer must be in newtons. 1.50 means 1.5 times 10 power negative 12. That's enough for this video. Let's complete in another video. God save all of you guys.